Katsuko Saruhashi was a Japanese geochemist whose work revolved around the study of nuclear fallout in the Pacific and the study of carbonic acid substances in natural waters. She worked at the Japanese Transport Ministry's Meteorological Research Institute for 35 years. Throughout her life, she received numerous awards and recognition for her work. She was an amazing promoter for women in science, and she founded the Association for the Bright Future of Women Scientists as well as the Saruhashi Prize. Although having faced many challenges as a woman scientist during her time, she made a great impact in the field of science as she studied the ocean.
Hello, my name is Jasmine. Today I'll be interviewing Katsuko Saruhashi. She came all the way from Tokyo, Japan. Katsuko is known for her work in geochemistry, especially the work she did detecting the nuclear fallout levels in the Pacific. To start us off, could you give us a little rundown of your life?
Yeah, I guess we have to start somewhere. As you mentioned earlier, I'm from Tokyo, Japan, and I've lived there my whole life. I was born on March 22nd, 1920, and ever since I was little, I've always wanted to know what caused rain, but I never did something about that interest until later in my life. I was always known to be shy and introverted, yet curious about everything inside my mind. My parents are Kanuhari and Kunu Saruhashi, and I was spoiled by my parents and my older brother Ichi. I was always mocked by my ironic name, which directly translates to strong-minded or victorious. I was always seen as the opposite of that, so I just lived life as an ordinary girl until later on, pretty much.
Katsuko did not begin her work as a geochemist until she was 21 years old. At that time, she worked at an insurance firm. She was a shy girl, curious about everything, desperately wanting to get an education and learn about what she had always wanted: what caused rain.
Then how did you get to where you are if you were just an ordinary girl for so long? What led you to start your journey of studying the ocean?
Well, ever since I was a little girl in middle school, I would watch the raindrops slide down the glass window in the classroom. I wanted to know what caused rain. At first, my parents were objective to the idea of me going back to school at age 21 and quitting my job at the insurance firm. They were very supportive of my education, and my mom eventually started to encourage me to gain technical knowledge and be financially independent. My mom saw how many women in the world struggled without a husband or father during World War II, and that none of them had a sufficient education or training to really have a successful career. With that in mind, she wanted me to be different, so she urged me to go, and that's what I did. I went to school to start my educational journey.
During the time she wanted to go to school, World War II was happening. Many women were going about their lives without careers and very little professional training. They lived without husbands or fathers, and Katsuko and her family watched as these women struggled. Katsuko wanted to be different, and her mom eventually agreed with her and allowed her to go to school. At age 21, she quit her job and began studying chemistry at the Imperial Women's College of Science, now known as Toho University.
You're brave for going to school at 21. People assume you are already too far in life by that age to get anywhere, but you proved them wrong. So tell me about your education. Where did you study?
Well, I started off by receiving my undergraduate degree in chemistry from the Imperial Women's College of Science. I graduated in 1943, and then right after, I took a position in the geochemistry laboratory at the Meteorological Research Institute. There, I worked with my amazing mentor, Miyaki Yasuo, and I began studying oceans and the carbon dioxide levels in seawater. I then went back to school in 1957, where I received a PhD in chemistry from the University of Tokyo. I was the first woman to graduate with a PhD in science. Then, from 1973 to 1978, I worked with Teruki Kawaza, where we measured the pH of every rainfall event for 5 years, and then I retired this year in 1980.
Katsuko had a long journey working as a geochemist. She graduated with her undergraduate in chemistry and immediately went on to do research regarding carbon dioxide levels in seawater. She developed the first method for measuring CO2 using temperature, pH, and chlorinity. This is known as Saruhashi's table. This method that she created is now used as a global standard, yet it has turned electronically. Most importantly, from this part of her research, she discovered that the Pacific Ocean releases more carbon dioxide than it absorbs, a concept that can cause substantial consequences today as the climate changes. On top of her research with CO2 and seawater, she also studied ocean-borne nuclear contamination. The United States continued to perform nuclear tests in the Pacific Ocean, although World War II had ended years prior. Katsuko and her colleagues at the Geochemical Laboratory were asked to investigate the cause of death of many Japanese fishermen who became ill after traveling through the testing site. Her results showed that radioactive fallout released during the testing had reached Japan within 18 months. If the testing continued, the entire Pacific Ocean would be contaminated by 1969, proving that nuclear tests in the middle of the ocean can quickly lead to severe and dangerous consequences.
Wow, what a long journey you had. Along your journey, did you receive any awards? Personally, how do you think you have contributed to the field of chemistry?
Yeah, I've actually received quite a few awards. As I mentioned, I was the first woman to earn a PhD in science, and in 1958, I established the Society of Japanese Women Scientists. I did this in hopes to promote women who are involved in the sciences. Then, in 1979, just last year, I was named executive director of the geochemical laboratory that I had worked in for years. Then, this year, I was the first woman elected to the Science Council of Japan. I do feel like I've contributed a lot to the field of chemistry. I developed Saruhashi's table that geochemists still use and discovered the negative effects of nuclear testing in the Pacific Ocean, and I contributed to empowering other women scientists involved in the field of chemistry and other areas of science.
Additionally, from stated in the interview, Katsuko won the Avon Special Prize for Women in 1981 for promoting peaceful use of nuclear power. Katsuko established the Saruhashi Prize in 1981, which was an award given yearly to a female scientist who serves as a role model for other women scientists. In 1985, she was the first woman to receive the Miyake Prize for Geochemistry. In 1993, she won the Tanaka Prize for the Society of Seawater Sciences. As by her many awards, she contributed greatly to the field of chemistry. She was the first woman to receive quite a lot of awards. On March 22, 2018, Google displayed a Google Doodle honoring her and her work. Years after her research, she is still honored to this day and a significant figure in the field of chemistry.
I definitely agree with you on that. With all this talk about promoting women, did you face any challenges throughout your years doing research?
Yeah, I did face many challenges during my research. Being a woman scientist, many other scientists questioned my intelligence and the accuracy of what's known as Saruhashi's analysis. I was widely known as an expert of microanalysis, but yet people still continued to question me and doubt me. A very specific example of how I was mistreated was when I was invited to analyze two different methods of measuring radioactive materials in seawater at the Scripps Institution of Oceanography in San Diego. I was set to work in a wooden hut, apart from everyone else. I was put at a disadvantage, but that's okay because despite those disadvantages, I was able to provide a more accurate measurement of the samples of radioactive material. I did face a lot of challenges, but that is what motivated me even more and what caused me to create the Society of Japanese Women Scientists.
Even though you went through all of that, you will always be known for your amazing work. Thank you for doing this interview for me, and thank you for joining us.
Katsuko's intelligence and methods that she developed were always questioned. Her being a woman definitely impacted the way people viewed her as a scientist during her time. Katsuko was invited to the Scripps Institute of Oceanography in San Diego to compare different methods of measuring radioactive materials in seawater. While she was at Scripps Institute of Oceanography in San Diego, Theodore Folsom, the leading researcher of the radioactive fallout, made Katsuko work in a wooden hut outside of the off-limits to women labs. The sample that Katsuko was given to analyze was 20% lower in concentration than given to Folsom. The lower the concentration a sample is, the harder it is to analyze. Katsuko was at a disadvantage in many ways, yet she still proved a more accurate measurement of a sample. Despite all the challenges and discrimination she faced, she persevered and became known as one of the best women geochemists. In our Chemistry 102 class this semester, we spent a lot of time in the lab and in class discussing pH and acids and bases. We performed titrations, dilutions, worked with indicators and solutions, and much more. We learned about the dangers of highly acidic or basic solutions. Katsuko spent a lot of her career testing CO2 levels in seawater, where she tested the pH of the water. A lot of her work involved her and her colleagues testing the pH levels of something. Learning that the pH levels of the Pacific Ocean were falling, the knowledge we have regarding pH and acidity allows us to understand how dangerous the water can be as the pH lowers. We learned the basics of acids and bases and pH levels, but Katsuko really went into depth with these concepts during her time of research. Katsuko Saruhashi died on September 29, 2007 of pneumonia when she was 87 years old. She will be remembered for her work in geochemical science as well as her efforts to promote women involved in science.